Users of mobile phones and other mobile devices are always looking for longer battery life. So it is a constant goal in design to better understand the battery current needs of the device. As a starting point, it is important to test the mobile device and battery individually when determining and optimizing runtime. However, a battery is not an ideal voltage source. Its characteristics interact with and influence the host mobile device's power consumption. Because of this interdependency, a number of unique and useful insights are obtained only when you perform a rundown test on a device with its battery together as a system. This is the best way to obtain the most realistic performance and runtime data to serve as a baseline for comparison with other measurement methods. You can also compare the battery capacity and energy obtained in actual use against the battery manufacturer's ratings to determine if there are any significant differences. It is important to verify the low battery shutdown threshold and also the full battery charge termination point for rechargeable batteries. This will tell you if the mobile device is making full use of the battery. This diagram shows a conventional setup for conducting a battery rundown test. In particular, high-speed digitization of the current is essential, as it provides many detailed insights. A 50 kilosample per second sampling rate is a good starting point for logging pulsed battery current drain signals of wireless devices. It is also a recommended rate for some mobile phone test standards. Accurate measurement over an extended dynamic range is also essential for obtaining meaningful results due to the high peak, low duty cycle, and low average values typical of pulsed current drain signals. Depending on the operating mode of the device under test, the crest factor can be several hundred. High crest factors consume the instrumentation's dynamic measurement range, limiting achievable accuracy. This is even more of an issue when you consider the current shunt peak voltage drop should be below 50 millivolts, so it does not unduly influence test results. It is imperative that the instrumentation has sufficient gain, dynamic range, and accuracy for good results. Conventional instrumentation usually falls short of meeting these requirements. A second independent measurement channel is also needed to log the battery voltage simultaneously with the current. Together, they provide the key insights necessary from a battery rundown test for analyzing and optimizing the runtime of the device. We conducted a battery rundown test on a GPRS smartphone using an Agilent N6781A 2-quadrant source measure unit to log the battery rundown voltage and current. The N6781A and the N6705B mainframe have a number of unique features and advantages that provide improved accuracy and greater insights, specifically when you conduct a battery rundown test. It offers an independent DVM input for logging the battery voltage, and it is a true zero-burden shunt, eliminating the voltage drop problem of conventional shunts. Seamless measurement ranging provides accurate current measurement of signals spanning from nanoamps to amps in one continuous logging measurement. This eliminates the dynamic range and accuracy limitations of conventional fixed-range instrumentation. A logging resolution of up to 20.48 microseconds and underlying sampling resolution of 5.12 microseconds assures accurate measurement for most pulsed signals that you are likely to encounter. Battery rundown test results captured and displayed using the Agilent 14585A control and analysis software is shown here. Placing measurement markers at the start and shutdown points shows that the average current was 0.233 amps and the peak current was 1.29 amps. The charge and energy delivered by the battery were 843 milliamp hour and 3.19 watt hour, respectively, and the mobile phone ran for 3 hours 38 minutes before shutting down at 3.44 volt low battery condition. Based on these results, findings include the delivered charge was 16% less than the capacity stated for the battery. The battery discharge termination voltage was higher than the target value. As you can see by this example, performing a battery rundown test yields unique and useful insights that complement the other test methods used in optimizing battery runtime on mobile wireless devices. For more information, visit the Agilent website at www.agilent.com/find/battery N6781.